Hello, my dear students, and welcome back. I know your exams are just around the corner, and sometimes this chapter on decimals feels a bit tricky, right? But don't you worry at all. Trust me, it's actually super simple. In the next few minutes, we're going to make this chapter so easy you'll feel like a pro. So let's jump right in. So let's start with a little story. Imagine Sonu is helping his mother fix a toy. He picks up a screw, tries to fit it in, but it's just a little too long. He picks up another one that looks almost the same, and poof, it fits perfectly. Why did that happen? As you can see, the screws look almost identical, but one is just a tiny bit longer. This tells us something really important. Sometimes, whole numbers like 1 centimeter or 2 centimeters are not enough. We need a way to talk about all that little space in between the numbers. So how do we do that? How do we measure those small spaces between the marks on our ruler? How can we describe something that's a little more than 2 but not quite 3? Well, this is exactly why we need decimals. They're the key to unlocking these in-between measurements. And here is the solution. Just look at that bottom ruler. See how 1 centimeter is now split into 10 equal tiny parts? Each of these little parts is called a tenth of a centimeter. So now we can measure that screw exactly. It's 2 whole centimeters, and then, let's count, 7 of those tiny tenths. So its length is 2 7/10 centimeters. See, so much more accurate. This idea of tenths is the first big step. It's our entry into this amazing world beyond just whole numbers. So let's get to know them a little bit better. The idea is really simple, Bacho. Imagine you have one whole thing, maybe a chapati or a bar of chocolate. If you cut it into 10 perfectly equal pieces, each one of those pieces is called a 1/10. And of course, if you put all 10 tenths back together, you get your one whole thing back. Simple. And we can use this to measure anything. Look here at these examples from your book. The eraser is 2 full centimeters long, plus 3 of those little extra tenths. So we say its length is 2 3/10. And what about the pencil? It's 3 whole units and then 4 more tenths. It's a really easy process. First, count the whole units and then just count the extra tenths. That's it. Okay, time for a quick quiz for my little geniuses. This one is straight from your textbook. We know the length of Sonu's lower arm and his upper arm. So what's the total length? Why don't you pause the video for a moment and try to solve it yourself? I know you can do it. All right, are you back? Did you get the answer? Let's do it together, step by step. First, we add the whole numbers. So 2 plus 3 is 5. Easy. Next, we add the tenths. 7/10 plus 6/10 gives us 13 tenths. 13 tenths. Now remember, 10 tenths make 1 whole unit, right? So 13 tenths is actually 1 whole unit with 3 little tenths left over. So we take that 1 whole unit and add it to our 5, which makes it 6. And what's left? Just the 3/10. So the final answer is 6 3/10 units. That's how it's done. You are all doing it so well. I'm so proud. But what happens when even tenths aren't small enough to be accurate? Let's look at another little puzzle. So someone folded a piece of paper. When we try to measure it, look closely. It's a little bit longer than 4 4/10, but it's not quite at 4 5/10. Oh no, it's stuck right there in the middle. What do we do now? We need to zoom in and get even more precise. So what's the solution? How can we possibly measure that tiny little space? Well, what if we took each of our tiny tenths sections and divided them into 10 even tinier parts? What would we get then? You got it. Let's zoom right in. If we divide each tenth into 10 little parts, and we know there are 10 tenths in 1 whole unit, that means we have 10 times 10, which is 100 tiny parts in just 1 unit. Wow! And each of these super tiny parts is called a 100th. So here's the main idea to remember. A 100th is 1 part out of 100 equal parts. It's what you get when you divide a whole thing into 100 pieces. This lets us become incredibly accurate with our measurements. Now, you know writing 4 4/10 and 5/100ths all the time? Oof, that's a lot of writing. My hand gets tired just thinking about it. There has to be an easier way, a shortcut. And there is. It's time for you to meet the real hero of our story today. Writing out these long fractions is just clumsy. And in mathematics, we are always looking for smarter, simpler ways to do things. A shortcut. And here it is, the decimal point. This little dot is like a superhero. It just sits there, right after the whole numbers, and it basically says, okay, everyone, everything that comes after me is a fraction. It's a simple, brilliant way to keep our numbers neat and clean. This place value chart really shows you the magic of the decimal point. Look at the number 705. That's 7 hundredths, 0 tens, and 5 ones. We all know that. But now look at 70.5. The point tells us we have 7 tens and 0 ones, and then, on the other side, 5 tenths, or 7.05. That means 7 ones, 0 tenths, and 5 hundredths. That one tiny dot is a magical separator that tells us exactly where the whole numbers end and the fractions begin.
Okay, so now you know all about tenths, hundredths, and our superhero, the decimal point. You have all the skills you need, so let's try a real exam-style question. Don't be scared, you can totally do this.
Here we go. We just need to add these two numbers. I know, it looks long and complicated, but remember our strategy. We just break it down into simple, easy steps, just like we did before. Let's solve this together, step by step. First up, the whole units. 15 plus 2 gives us 17. Great. Next, the tenths. 3 tenths plus 6 tenths is 9 tenths. Perfect. Finally, the hundredths. 4 plus 8 is 12 hundredths. Now, wait a minute. 12 hundredths is more than 1 tenth, isn't it? We can think of it as 10 hundredths and 2 hundredths. And what is 10 hundredths? It's the same as 1 tenth. So we carry that 1 tenth over to our tenths column. That means our 9 tenths becomes 10 tenths. And what is 10 tenths? It's 1 whole unit. So we carry that 1 whole unit over to our 17, making it 18. And what's left? Just the 2 hundredths. So our final answer is 18 and 2 hundredths, which we write as 18.02. Amazing work! All right, one last challenge for my brilliant students. Take a look at these 3 fractions. Can you tell which one is the biggest and which one is the smallest? Just looking at the numbers 3, 3, and 33 can be a little confusing. So let's not guess. Let's actually see it. Here's a ruler that's been divided into 100 tiny parts. Let's find the first one, 3 tenths. We know that's the same thing as 30 hundredths, right? So we just go to the 30th tiny mark. There it is. Now, where would 33 hundredths be? That's just 3 little steps further along. And what about 3 hundredths? Oh, look, it's way, way back near the beginning. It's so tiny. So now it's super clear, isn't it? 33 hundredths is the longest, and 3 hundredths is the shortest. When you see it like this, it becomes so easy to understand. You all have been absolutely fantastic today. We've peeked beyond the decimal point and learned all about tenths and hundredths. So I have one final question for you to think about. What if we needed to measure something even tinier than a hundredth? What do you think comes next? Give it a thought. You are all superstars, and I know you are going to do wonderfully in your exams. Keep up the amazing work.